The distance of after that, after it's back, so the middle after that, there's
Right, now you remember this, right? Then C is for average C. And I'm saying I used to find average C, I click through it. And they give you the different students.
Jin Xuan, take up your worksheet from last week. You still have it, right, Jin Xuan? Come, let's see. Any questions before we start? No, all fine. Right corner. I must use this one. Okay, there's.
But it's not.
All right, so come, let's look at our.
Your question properly.
Let me double check something.
You can start very quick. The first few.
All right, look at question 1.
We all need to remember this.
Me, what's the answer? Okay, shouldn't get it wrong. Of course, anyone has questions, please voice out. Because, Angel. Good. Right. You shall learn this in primary school, like rays travel in straight lines, and you have an optic object. Light rays reflected when they fall on me. Okay, again, shouldn't be a problem. Ancient following, right? Okay. Right, which one is not a use of concave mirrors? Well, I did talk a bit about concave. Yeah. Okay, just a couple of things. I think I've written a few notes there. Correct. For a security mirror, is convex. Okay, why? Because I look at this.
You see, I told you even without calculator.
Yeah. Now, basically, this is the keywords I want you to take note. A convex allows a wide field of vision.
Right?
Right, so imagine you have something like this. This is convex. Right, basically, it can take in light from a wide angle.
If they told you, let's say, 3 hours.
Onto a certain point. Right, so it allows you to see a wide field of vision. But there's a disadvantage. The disadvantage is the image is diminished. Angle, the image that you observe is smaller than the object. That is the disadvantage. Advantage is wide field of vision. Disadvantage is a diminished image. Now, of course, probably you can realize the opposite is true for concave mirror. So basically, for a concave mirror, okay, maybe I write another thing. Concave Remember, these are still mirrors. This is not refraction. This is reflection. So concave mirror advantage. Tell me, what do you think the advantage is for concave mirror? Yeah, me. What's the advantage? Yes, good. Image is magnified, and of course, the disadvantage. All right. So what I'll say is, it's a narrow field of vision. All right. So yeah, just keep all this in mind. And well, of course, the more obvious one is for this case, you want a security mirror in order to see a wide field of vision. Right. So it uses a convex one. Which of the following shows the correct direction of a light ray that travels from glass to water? Angel, what's your answer? Glass to water. Yeah. Yep. May, do you know why you're wrong?
You know, Japanese one.
You know. Yeah. Okay, then I'll just go on. Of course, Xing Quan, if you have any requests, please voice up or type in the chat box. Okay, let me go on. Number 6, which indicates the angle of incidence. Better get this right, May. Okay. Incidence means the ray that is going in, and the angle is always between the ray and the normal. Force, which one is force about the spectrum of white light? Here. The This one is trickier. Now, white light is a mixture of different wavelengths. Even though you don't really. AJ, is your side talk about wavelengths? No one. Yes, Hey, your side, did they mention about wavelengths? I don't think so, right? So anyway, 7 colors. All right, fine. I don't think anyone wants to argue against it. Electromagnetic spectrum. That means all light, including ultraviolet, infrared, they are part of the electromagnetic spectrum. ROYGB colors, which you need to remember. In that order, of course. Tell me, what is a prism? In what kind of shape? Made of? Okay, I think you get the idea. Prism is a triangular object made of glass. But what's the purpose of a prism? Angel? What's the purpose of a prism? What does it do? Okay, it bends light, meaning it refracts light. That is the key word. It bends or refracts light. It doesn't reflect light. I mean, it does not, but that's not the purpose. All right, it only reflects to a small extent, but the main job is to refract. All right, so, well, of course, your answer is C. I mean, the statement C is false, so that's your answer. Okay, Ken, let me go on. How about number A? Which of the following occurs when white light passes through a prism? Major? B, yeah. B for dog. All right, it should be C, but Major, why C? What is this? What are these two? What is this and what is this? Red and violet, good. Which one is red? Which one is violet? Good. Okay. Maybe you. That's right. Okay. Do you know why it's red and violet? Red is. Oh, red is what? Faster. Let's ask Angel. Why is red here and violet at the bottom? I mean, you're right. You're right. This is red. This is violet. What do you know about the rule? Basically, red you bends less. Violet is going to bend more. I mean, if you just look at it, I think what do I mean? That means you must look at the original direction. This is the original direction of the light ray. So this angle is less than this angle. That's the meaning of bending more or bending less, as in bend less from the original direction. Okay, can me. All right, next one. Will the fish appear to be yup me? Okay, should be. All right, it should be shallower, but it's still along the same vertical axis. I don't think I need to draw that out. Which of the following shows the correct colors represented by X, Y, and Z? Sorry, D, yeah? Yep, it's the same thing. Okay. Basically, red bends less, violet bends more. In the end, they combine back together. Label the normal, angle of incidence, and angle of reflection. Okay, this one shouldn't be a problem for anyone. Normal is this one. Guys, just remember this word normal. Normal is not just normal as in English, but normal in maths and science means perpendicular. Probably you've encountered this in your maths already. So just take note of this word normal means a perpendicular line. All right, so angle incidence. You should get this by right. And of course, you have your reflected ray, and of course, this is R. All right, very standard things. So those two are. These two characteristics of an image formed by a plane mirror. So take note, plane mirror, not concave mirror, not convex mirror. Yeah, two characteristics. Okay, yep, laterally inverted, same elevation, same size, right? Same distance from the mirror. Virtual, if you remember that word. So yes, I think we mentioned this before. I don't think I need to write down. Complete the path of the light ray that falls on the prism until it as well. Okay, now, well, of course, the diagram wasn't, they don't give you any angles, but I assume it goes straight in. Gets reflected. Line is silver. That means this acts as a mirror. Of course, please draw your arrows as well. Gets reflected again. Now, if I were you, draw a right angle here because it goes straight in. No refraction. Right angle here. And you're supposed to include the normal. So make sure you have a dotted line to represent the normal. There.
What's your speed?
Arrows are important for light rays. Inside here, there are no imaginary rays, so there's no need to draw any imaginary lines except for the normals. Okay, come, let's go on. Angel, okay? This is an interesting question. I think I touched on this last week. They actually asked for one difference, but of course you can always mention more than one difference between the two. Yeah, Angel. Okay, what's the definition between, for each of them? Light ray is directed.
Oh, guys, I'm sure it's very.
Whereas refraction, I mean, you can use light or light ray, it doesn't matter that much. Light is bent.
That's why questions are because everybody makes.
Well, of course, I mean, you can write quite a few, but let me just touch on the important ones. Now, one key difference for reflection is on an opaque surface, or at least translucent. Whereas refraction is two. Notice the two prepositions. One is on, one is two. Two are transparent. or at least translucent surface. As I said, highlight the prepositions. One is on, one is through. Okay, reflection doesn't go through, it just stays. But of course, you can write a bit more. Angle of incidence equals to angle of reflection. Whereas angle of incidence obviously does not equal to angle of refraction. Okay, all this you should be aware of. Okay, just 1 mark, so write anyone. Okay, let's go on, unless you have questions to ask. Objects appear red, green, yellow, and black. What will their colors be when they're placed under blue and yellow light? Fill in the blanks in the table below. Okay, this one is tricky. All right, first, I've under what, like 4 different objects appear red, yellow, green. What will their colors be? And blue and yellow. Like, okay, so you have 4 objects here. One. So the 4 objects. Under blue light, it appears black. Under yellow light, incher. Black. This one is tricky. I mean, okay, maybe does your school teach this one? The different colors? No. Your school does, right? Does it? It does. That one, you have to look at the color view, which I didn't mention last week. Let me see, where's my color view? Yeah, this one. This is the theory. Alright, according to this theory, white color has, white light has 3 colors. And green, RGB, or red, green, blue. That's this theory, but there are other theories as well. So if I combine red and green, I get yellow. Combine red and blue, I get magenta. Combine green and blue, I get cyan. If I combine all 3, I get white. So that's the theory. So basically, RGB red, green, and blue. Take note, this is not watercolor. This is not paint. Paint will be a different theory. Paint is based on red, green, and yellow. But this is light. Light is based on RGB. Now, the secondary colors will be these 3. Yellow, magenta, and cyan. CMY. Normally they call it CMY. So, can take note of this. Let's go back to the question. So, what is green and red? Yeah. So this is how I would work out the equation. Okay, so what you need to know is yellow is actually not a pure color. It's made of green and red.
The 3 travelers has the 3 travelers
So the theory is this. Let's say I have a brick object. Now, if I have white light, what is white light? RGB theory, so it's R, G, and B. So what happens is, if I have white light shining on a red object, I will have red, green, and blue. But what will happen next? This red object, it is going to absorb the green and the blue. So are absorbed. Okay. But if you shine blue light on it, what will happen to blue light? Absorb. Okay, blue light will be absorbed by the red object. So imagine I have a red object again. I only shine blue light, nothing else. No light reflected backwards. I mean, no light reflected into your eye. That is why you see black. But how about yellow? Same thing. I have the same red object. What happens? The red will be reflected. Because the green is absorbed. Only the red is reflected, which you can see. Me can that's the answer. Green object. Green object means it can reflect green only. Black object, Angela, what do you think? What can it reflect? Nothing good. How about the yellow object? If you shine yellow light on it, I mean, too easy lah. Of course, you're going to see it's yellow. Light on it, me, what do you think? Yeah. Can I need me to elaborate further? Okay, what light rays are surface and the light rays. Draw the direction of light rays after they touch the surfaces and label the incident, reflected, and normal when necessary. Okay, I think nothing new here, so I just simply draw it out. Check your own answers. obviously silvery surface is a reflection. And reflected. Obviously, refraction will occur, but maybe you want to take note, reflection is possible too. 80% refracted, 20% reflected. Normally not fully one or the other. Well, I still need to draw the normal. And refracted one. Make sure you have the arrows there. Check your angles. Okay, next. A and diagram B. Did you write anything for this box? No. Angel, what do you think? A? A? Well, actually nothing much. Basically, I've mentioned all I want to say already. Alright, basically in A, you have ray, or for diagram B, both reflected. Okay, so comparisons within the light rays.
But when it does E, which distance over time,
Well, of course, you have the same angle. Actually, you're talking same angle as incident ray. Okay, for diagram B, of course, your reflected ray has the same angle, while the refracted one has a smaller angle.
You know, Joy, one day I snapped, I'm going to take a shit. Oh no. Oh my, no, don't worry, I'm not going to snap it.
Actually, the last one is something that we have done earlier. Alright, basically reflection is like ray. Okay, ray lah, no need to add the word lah. Whereas for diagram, part of the light goes through the Yep, that kind of completes it. Any questions, anyone? No. Ding Xuan, any question? May you have any other questions about light? Oh, internal reflection. Oh, okay. Need to know formulas? No need. Measure. You need to calculate? No need, right? You need to calculate. Serious? You need to calculate as well, right? Can you remember? Formula that you remember? Yes. Okay. What formula do you remember? You mean they'll give you what?
For question 9, the first question and average speed of the
Oh,
I feel like currently things so I'm just trying to make sure that I don't have everything. So like this question just asked like why does this occur?
okay. Okay.
So again, James,
Picture can remember internal reflection? No. Okay, come, let's quickly go through. Where shall I draw it? But anyway, let's have it here.